Hard as it may be to believe, ladies and gentlemen, I was once an 11 or 12-year-old math student myself. And at that age, I probably just wanted to know, how do I get the right answer? So you might have just watched a video about proving that -1 times A is the opposite of A. Well, um, that's part of math. That's an important part of math, to be able to prove something, or at least to be able to understand somebody else's proof. And I didn't make that proof up. I read it somewhere. There's very little that's new under the sun. What we're doing is we're trying to pass on to you, an older person trying to pass on to you, the vast heritage of math. Maybe someday you'll learn enough to make new contributions yourself. But let's get to the nuts and bolts of being a sixth grader. How do I get the right answer? It's very simple. I told you that multiplication and division is easier than addition and subtraction. With addition and subtraction, we had to understand that vector business. And then we had to define subtraction to be the addition of an opposite. That takes a little getting used to. This is pretty simple. When you're multiplying or dividing two numbers, if the signs are the same, the answer is positive. And if the signs are different, the answer is negative. It's as simple as that. A challenging thing will be not to confuse the two sets of rules. Try not to confuse what you've learned about addition and subtraction with what you're now learning about multiplication and division. That's the tough thing. But again, any two numbers being multiplied or divided, if they're both positive or both negative, same signs, the answer is positive. If the signs are different, if one is positive and one is negative, then the result will be negative for both multiplication and division. One thing that is common to addition on the one hand and multiplication, division on the other, is this idea of, do the two numbers have the same sign or different signs? And we think when we're adding two numbers with the same signs, it's a similar process in our minds. When we're multiplying two numbers with the same sign, it's even more direct. It's not just it's the same process in our mind, but we can definitively say the answer is positive. Okay? 3 times 4 is 12. And according to this rule, which I've now introduced you to, -3 times -4 is also positive 12. This is one of the most interesting topics of middle school math. One of those things which we kind of struggle with. Different teachers are going to present it in different ways. I'm not going to be content to tell you, to dictate to you that -3 times -4 is positive 12. I want to convince you why. And we've started to do that by looking at the fact that -1 times A is the opposite of A. So we're gonna look further at this, but I just want to lay it out for you and convince you about how easy it is. We could also have on the other side here, we have the other situation where the signs are different. 3 times -4 and -3 times 4. Either way, whether it's 3 times -4 or -3 times 4, the signs are different. One is positive and one is negative. So the product is negative. Each of these is -12. Okay? So on the left side, when the signs are the same, the product is positive. On the right side, when the signs of the two numbers are different, the product is negative. And it works the same way with division, with quotients, which we may or may not get to in this video, but the rule for multiplication and division is quite simple. Now let's look a little bit at the why of it. Whether we are a student or a teacher, it's a little bit easier to accept that 3 times negative 4 is negative 12, and 4 times negative 3 is negative 12. It's a little easier to accept those than it is when we're multiplying two negatives, because we have this initial definition of multiplication that we learn in third grade, that multiplication is repeated addition. So we can think of 3 times negative 4 as negative 4 plus negative 4 plus negative 4. We fall back on addition. And when we add those three negative 4s together, we get negative 12. And in a similar way, 4 times negative 3 can be thought of as negative 3 plus negative 3 plus negative 3 plus negative 3, 4 negative 3's added together, which is negative 12. And by the way, we learn all of this integer operation two numbers at a time, but you need to be able to extend it to operating on several numbers. Negative 3 plus negative 3 is negative 6, plus negative 3 is negative 9, plus negative 3 is negative 12. What about these? How many times do you add together the negative 4 here? I think I've heard people suggest, well, if we want to add negative 3 negative 4s together, we have to add 3 4s together. Because adding negative 4 negative 3 times is like adding 4 3 times. Well, as it turns out, we're going to show that that does work, but does it, are we convinced of it? Does it sound, oh yeah, that's got to be true? I don't think it should. It's a difficult thing to understand, to appreciate intuitively, without getting into some of what we might call, again, a proof. Okay? Now, before we get to these hard ones, and we're facing an age-old question of middle school math. Why does a negative times a negative equal a positive? I've suggested up here that it's a little easier to accept that positive times negative is negative because of the repeated addition. But let me point this out. Let's look at this 3 times negative 4. And let's apply something that we learned in the proof video about multiplying a number by negative 1. What if we think of 3 times negative 4 as being 3 times negative 1 times 4? Okay, we're looking at 3 times negative 4. You might be convinced that it's negative 12 based on the repeated addition. But we proved that negative 1 times 4 is negative 4. Negative 1 times 4 is the opposite of 4. Here's another fundamental assumption of mathematics with addition and with multiplication. They are both commutative and associative, which when you put those two together, we can say that when we have to multiply a bunch of numbers, we can do it any way we want. We can rearrange the order and the grouping any way we want. So this could be thought of as negative 1 times 3 times 4, right? We thought of the negative 4 as negative 1 times 4, which we proved that's true. Negative 1 times the number is the opposite of the number. And we've got a times 3 there. So we have 3 times negative 1 times 4. Well, let's think of it this way. Rearrange the order. Negative 1 times 3 times 4. And we're allowed to do the 3 times 4 first, which is 12. And then negative 1 times 12. We have proven that that's negative 12. You see, I'm not going to rewrite that. Okay, it's right here, negative 12. Negative 1 times 3 times 4. 3 times 4 is 12, and negative 1 times 12 is negative 12, the opposite of 12, which we have proven in a previous video. We could do a similar thing here with 4 times negative 3. Think of it as 4 times negative 1 times 3. We are allowed now to write, instead of negative 3, negative 1 times 3. We proved that that's true. And rearrange these, and it works out the same as before. Negative 1 times 4 times 3. 4 times 3 is 12, and negative 1 times 12 is the opposite of 12, negative 12. For these more challenging, and of course this is just, this is the same problem. Multiplication is commutative, even with negative numbers. So this is only one problem here. Why does negative 3 times negative 4 equal positive 12? We'll look at that next. The approach to negative 3 times negative 4, now we know according to the rule the answer is 12. But the approach to understanding it is going to be similar to how we just approached 3 times negative 4 or negative 3 times 4. We're going to rewrite negative 3 as negative 1 times 3. And we're going to rewrite negative 4 as negative 1 times 4. We are allowed to do that because we have proven that negative 1 times a number is the opposite of the number. We have proven that negative 1 times 3 is equal to negative 3. And we have proved, and in the same way, negative 4 can be thought of as negative 1 times 4. So it's the same two numbers being multiplied together, except now we've represented it as 4 numbers multiplied together. Multiplication is associative and commutative, meaning we can multiply these 4 numbers in any order and grouping we want to. So how about this grouping? How about negative 1 times negative 1 times 3 times 4? Okay? Well, we can do the 3 times 4 first. We can jump up ahead to these two. That, of course, is 12. But now, what about negative 1 times negative 1? I'm actually going to show you a proof of that to sort of close out this video, or this portion of the video anyway. But we don't really need to consider the specific case of negative 1 times negative 1. Do you want to take a guess at what you think negative 1 times negative 1 is? Do you think it's 1? Well, it is. So we've reached the point where we have 1 times 12. 1 times 12, positive 12. Now, a word about this negative 1 times negative 1. We can think of this negative 1 as being a number that we're multiplying by this negative 1. We're multiplying this number by negative 1. So the result is the opposite of this number. But the opposite of that number is positive 1. So there you go. This is a demonstration of why negative 3 times negative 4 is 12, and this approach can be extended to any two negative numbers multiplied together. A negative times a negative is a positive. This is a proof that negative 1 times negative 1 is 1, or positive 1. It's extremely similar to the proof that we saw earlier as to why negative 1 times a number is the opposite of a number. Negative 1 times A is the opposite of A. This is a specific case of that. As I said before, when we were looking at negative 3 times negative 4, we ended up with negative 1 times negative 1 times 3 times 4. Well, you don't really need a specific proof of negative 1 times negative 1 being 1, because it can be thought of as part of the more general case that negative 1 times a number is the opposite of the number. Negative 1 times this number here is the opposite of this number, which is positive 1. But it might be helpful, might be instructive to just look at the specific case. Can we prove that negative 1 times negative 1 is 1? And we can, in a very similar way as the other proof. It depends on the fact that when you add two opposites, you get 0. So here we set up negative 1 plus something equals 0. If we can prove that negative 1 plus this something equals 0, then this something has to be 1, right? Because negative 1 plus 1 is 0. Or more specifically, 1 is the only number you can add to negative 1 to get 0. So if this statement up here is true, then negative 1 times negative 1 has to be 1. Okay. Well, Very similar proof. The first thing I'm going to do is multiply this -1 by 1. Okay? -1 times 1, or let me write it as 1 times -1. 1 times -1 is the same as -1 here. And now we look at what we have. We're adding two things together. 1 times -1 plus -1 times -1. This plus this. And each of those terms has a common factor of -1. There's a -1 here, and we'll pick one of the -1s there and factor it out, just like we did in the other proof about -1 times a equals the opposite of a. I took the -1 that appeared in each term and I factored it out, the distributive property backwards. -1 times 1 is here, and -1 times -1 is here. Now, we're not assuming that -1 times -1 is 1. You cannot assume what you're trying to prove, but you can just see it. There are two of them there. There's one here and one here. So if we take one of them outside, then this -1 in here times this -1 equals right there. Right? And -1 times 1 is that term. And once again, just like in the previous proof, 1 plus -1 is 0. So we get 0 times -1, and that does equal 0. So once again, we proved that -1 plus -1 times -1 does in fact equal 0. We can erase those question marks now. And the only number you can add to -1 to get 0 is 1. So this thing here, -1 times -1, has to be +1. We'll leave it at that for now. To review, for multiplying or, as we'll see later, dividing, if you're multiplying or dividing two numbers, if the signs are the same, the answer is positive, and if the signs are different, the answer is negative. So long for now.